this is Tiago from Coderversity, and in today's video I'm going to be teaching you SQL query performance tuning. Today you will learn how to set up a database, how to see the database for testing, to optimize SQL Server queries, and how to benchmark the query's performance. And for that, we will use SQL Server and Azure Data Studio. So what are we waiting for? Let's dive in. So I've already built the tables. I've built the customers, order items, and orders that are related. The customers have a customer ID that is a primary key, a name, an email, and an address. The order items, they have an order item ID, that is the primary key. The order ID, that is a foreign key that references the order primary key, and a product ID, a quantity, and a price. Also, and lastly, the orders. I have an order ID that is primary key, a customer ID that is the foreign key for the table customers, the order date, and order total. Now, for the sake of time consumption, I have already seeded the tables because it took me almost 10 minutes. So, for us not to wait, I will just explain to you the queries that I've used. So here I built a cursor which contains the numbers from 1 until 1 million. So this will select the 1 as a number and will make a union with number plus 1 until the number is 1 million. Because I want to insert 1 million customers, so I'll use each number to have, for the customer to have a customer ID, a customer name, email, and address as unique. And this will be the customer ID primary key. I did the same thing for the other tables, so for the orders and for the order items. And what is this max recursion 0? This option removes the default recursion limit of 100, allowing the cursor, the CTE, to generate the required number of rows. So if we check like this, the count of the rows of the customers, we should have 1 million. Exactly, 1 million. Then we have the order items, which should be around 30 million. And then we have the orders, which should be 10 million. Okay, so let's proceed for the query tuning. So let's clear this query page and let's start an example of an inefficient join. In this scenario, we want to retrieve the order details along with the customer names for orders placed within a specific date range. So let's do it. Let's select the o.order_id, c.name, o.order_date from the orders, which we have 10 million, and we will join with the customers to get what we have in common, so to get the corresponding rows by customer ID, where the o.order date is within this year. So this year, no, not 2023, because those are the dates I generated from 1 of January until 31 of December. And what do we need here? For the benchmarking, we need to set our statistics on, so that we can compare our elapsed time. And this is how we do it. We just type in set statistics time on, go, and go statistics time off. And then if we run, we can see that it will give us the current execution, the total execution time. So 7 seconds. And now let's do the plan. Let's check the execution plan to see what can we improve. So show plan XML, show plan XML off. Go. And there we have a schema to check which percentage of each operation we use. So we can see that the clustered index scan is the one that uses the most CPU and the most time consuming or execution. So we can just follow the tips. So it is telling us to create a non-clustered index on the table orders in the field order date, which includes the customer ID to make the bridge. So let's call it index order date include customer ID. And we create it. It's missing here. We create it. And then let's do the same thing for here, for this one. So index on orders, customer ID and order date. And now let's execute the plan again. So now we see that it decreased a lot and we are using just 28%. For the index seek, we are looking for the index in orders and an index scan on the customer's PK. So let's see how if this statistics, if this improved or not. It was around 7 seconds as well. Let's update the statistics, so this can update statistics on customers and update statistics so we have a refresh on orders. We run and then we go. And as you can see, the time didn't change much, but the cost decreased a lot. This is because we have a lot of orders. We have like 10 million orders and 1 million customers. So it's normal if you don't see any major change in time, but you can always check the costs to improve. So set show plan XML on, and then we set the XML off. And it doesn't have any other suggestions for us. So this is pretty much what we can do other than get rid of this join and this filtering. So up next, the complex filtering and sorting optimization. So let's say we want to retrieve orders with totals over 10 placed in 2023, sorted by their order total. So let's do this query. O.order ID c.name o.order total from orders O and join customers C on o.customer ID with the customer table customer ID, and where the order was made between 2023 001 and the end of the year. And the order total is above 10, and let's order by o.order total descending. So first, let's analyze the time. Statistics time, and then statistics time off. So we got the results and the execution time. It's taking a while. Remember, these are millions of entries, so 23 seconds. Now let's analyze the plan. The plan says that 60% of the costs is the sort, and it's telling us to create these indexes. So let's do it. Let's call it index on orders. By the way, I eliminated the previous indexes. Index orders, date and total. Include customer ID. Okay, and then this one that creates an index on orders. Index orders on customer ID, date and total. Now let's check the plan again. And we have here an index seek of 76%. And still, this is just the 76% out of this index scan and seek. But the sort is still 60% of cost. So the sort is here, the order total higher than 10 and the order by. Maybe we don't need the order by, or we can order just in our app. It could be something we can think about. So it was around 25 seconds. Now let's check again the show plan, and we have here a really good improvement. So let's check the statistics times. Statistics time on and statistics time off. We had around 25 seconds previously. Let's see how this improves, because even if it improves a little, this is millions and tens of millions of entries. So don't forget that. So it improved by 5 seconds. So what we got from here is that we can create indexes for a better search on just on the necessary fields, and we can sort either in the app that we need or in the wherever we need. We can do the sort later without getting the cost out of the SQL server. So this was a nice one. Next, let's analyze the pagination with offset and fetch. So We want to paginate the results for orders placed in 2023. So let's select them. Select, and let's select everything from orders where the order date is between 2023 from January 1st, you already know, and 2023 December 31. And let's order by order date. So let's check the time here. Order date, orders. So it's running, as you can see in here. Already at 15 seconds. And it went around 20 seconds. So let's check the plan here. It's show plan XML on and the set of. So the index seek here is 100%. The cost is on the index seek. But now let's not take the plan in consideration, and let's only take the statistics, because we are not having any hint for an index or anything. So let's only get the statistics where we had 20 seconds. Now let's try with offsets and fetch. In other words, pagination. So let's declare a page number as an int with 1 and declare the page size int as 100 and select the same thing. Actually, let me do this, and it's easier to go back and just copy what we had. Statistics time, and let's just copy here, and then we use the exact same query but with a pagination. So putting offset as the page number -1, because remember, when we get from the apps, they will always start with 1, because we start always with 0, so it's important to have this count here. Multiplying by the page size. So we want the page number and bring the page size rows, in this case 100 rows. And let's fetch the next page size rows only. So what we are doing is getting the offset from the page in question until the page size. In this example, we are using the first page, which is the page 0, versus the page size that will give us 0. So the offset starts with 0 and will bring us the next page size results, that is the 100 results. And if you remember, we wasted 20 seconds for this before the fetching and the offset using pagination. So let's see now. So now it was instant. It was instant, the execution. As you can see, it was CPU time 0 ms and elapsed time 0 ms and 100 rows affected, because we fetched the 100 rows. So this is a very, very efficient way to do pagination and bring results. Because let's be realistic, we will never want to display so many results within a whole year in a single page application, for example. Total execution time 40 milliseconds. So that wraps it up. We got to see the table creation and seeding, the join, the complex filtering and sort, and pagination performance tuning. With that, we used the show plan execution where we can see where the costs are higher and the statistics. So I hope you found this project helpful and that you learned something new along the way. If you followed along, congratulations. Don't forget to like this video if you enjoyed it and consider subscribing the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, just drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.